Now we learnt about classification of magnetic materials, and now we'll take down some problems. Before that, I'll give you one question, that is state Curie law in magnetism. Before the problem, we'll just try to answer this question. State Curie law in magnetism. So the statement. So this law gives the relation between the temperature and the magnetization, or I can say like temperature and the susceptibility. So first we'll write the statement and then we'll write the mathematical equation for this law. Curie law in magnetism states that Curie law in magnetism states that the magnetization in the paramagnetic material is inversely proportional to the temperature. Okay, or in other words, you can state it as the temperature of paramagnetic material increases, its magnetization decreases. As the temperature of the paramagnetic material increases, its magnetization decreases. So there is an inverse dependence of the temperature and the magnetization. You can also tell in terms of susceptibility. Susceptibility is inversely proportional to the temperature. As the temperature increases, susceptibility reduces. That actually means that the magnetization of a material reduces. And in magnetism, the paramagnetic and the ferromagnetic material obey this Curie law, whereas the diamagnetic material does not obey Curie law, and their susceptibility or magnetization property remains same as the temperature increases or decreases. Actually, in the previous problem we have drawn the relationship between the susceptibility and the temperature for a diamagnetic material, so you can refer that problem. So it comes as a constant, or constant value of susceptibility for variation of temperature. Now I'll write a mathematical equation for this. Now here, if M is the magnetization, let me write my mathematical equation for this. So M can be written as M as C into B by T, where C is known as Curie's constant and B is the applied magnetic field and T is the temperature in Kelvin and M is the magnetization. You can write C is Curie constant, T is the temperature, and B is the applied magnetic field. Okay, so next we'll take down another problem. You may note down the problem. and this problem is based on the classification. A uniform magnetic field gets modified. A uniform magnetic field gets modified as shown below, when two specimens X and Y are placed in it. When two specimens X and Y are placed in it. Identify whether specimen X and Y are diamagnetic, paramagnetic or ferromagnetic. Identify whether X and Y are diamagnetic, paramagnetic or ferromagnetic. A uniform magnetic field gets modified as shown below when two specimens X and Y are placed in it. Identified whether X and Y are diamagnetic, paramagnetic and ferromagnetic. Now the specimens are given like this. Now this is X. First one is X and the second one is Y, and I'll show you how the fields are getting modified. So in this case, only few lines pass through X, and for Y the most of the magnetic lines are passing through it. This is for Y. So identify X and Y. So we should know how this an external magnetic field behaves when these materials are kept in the magnetic field. We know for paramagnetic material only few magnetic field lines pass through it, or the paramagnetic material gets very weakly magnetized, or it is the magnetization property is slightly greater than diamagnetism, whereas ferromagnetic material gets easily magnetized. So here, because only one line passed through this X, I can say that X is a paramagnetic, because only one line enters the specimen, and here most of the line pass through the specimen, and hence we can see that because through Y most of the magnetic lines of force pass through, and hence specimen Y is ferromagnetic. So we can note down those things. Specimen X is paramagnetic. Why? Because only few lines prefer to pass through specimen X. Specimen Y is ferromagnetic. And in bracket, if you want, I will write, because most of the magnetic lines of force prefer to go through it. All magnetic lines of force prefer to go through it. Now if it was a diamagnetic, then how it would look. So this problem completes here, but I'll show you like if it is a diamagnetic, how field lines will look. If you take a diamagnetic specimen, now it repels in an external field, so the external field lines will go away from the material like this. So if the specimen given and the field lines are shown like this, then you can say that it is diamagnetic, because the field lines will go away from the material. So that is the difference between these two specimens when it is kept in a uniform external field. So you may have asked to draw the pattern of the magnetic field lines when the paramagnetic, diamagnetic and ferromagnetic materials are placed in an external magnetic field. Then you can draw these three figures. So either they will give you the figure to identify the specimen, or you may be asked to draw the figures which represents the field lines when materials like diamagnetic, paramagnetic, ferromagnetic are kept in that uniform field. Hope you understood this.